The force of one of these space rocks equals 10,000 Hiroshima bombs. This immense power, packed into a piece of land a mile across, Oumuamua, a secretive substance that once zipped through our nearby planetary group, has again sent shock waves throughout mainstream researchers. Elon Musk, a noticeable trailblazer in space innovation, uncovered that Oumuamua is back, and this time it's not the only one in its excursion. Elon Musk guarantees that its secret qualities contain a tempting clue concerning other star frameworks. This isn't the customary return of a divine entity. A return challenges how we might interpret space and its potential tenets. Go along with us as we unravel the implications and secrets surrounding Oumuamua's surprising return. Back in 1837, an unusual object arrived at an enormous achievement. It crossed a distance of 1,000 cosmic units from the Sun. For north of a century, this object proceeded with its journey inconspicuously, ever progressing towards our star. It was only after October 19, 2017, that humankind at last became aware of its presence. On that particular day, a picture captured by the Pan-STARRS 1 telescope at the University of Hawaii revealed a weak, sensitive streak. It was crossing the sky at a consistent speed, covering approximately 6.2 degrees every day. This mark denoted a significant moment. It was the first recorded interstellar guest, officially designated as 1I/2017 U1. This object was also given the name Oumuamua, which means a courier from afar, appearing first in Hawaiian. The discovery ignited a worldwide drive to observe Oumuamua through telescopes. Stargazers, including those from the SETI Institute, enthusiastically participated in observing the object, even sending off searches for potential extraterrestrial signs. Oumuamua appeared as a ruddy, cigar-shaped object comprised of rock. Its prolonged shape is striking, stretching up to 4 miles long and much longer than it is wide. Oumuamua has an aspect ratio that surpasses any asteroid or comet observed in our planetary system. Its elongated shape is highly remarkable and unlike anything we've seen before. Oumuamua was traveling at a speed of 196,000 miles per hour when it drew near to Earth. That is 10 times faster than a slug, which means it's highly unlikely that this article was part of our nearby planetary group. This time, scientists couldn't initially determine whether Oumuamua was an asteroid or a comet. So what's the difference between the two? Comets are made out of ice, while asteroids are rock. Initially, scientists thought it was a comet, but their classification changed to calling it an asteroid once it zipped past the Sun on September 9, 2017. However, they still thought of it as an asteroid until additional measurements showed slight acceleration, which is an indication of it being a comet. Yet the reality that Oumuamua sped up significantly more than we anticipated confused scientists for years. An intriguing trait of Oumuamua was its intermittent brightening and dimming every 7.3 hours. This behavior indicated its rotation, and its short rotation period suggested a more rigid and tough structure than the typically soft, snow-like material of most comets. Appearing dull red like certain moons in the outer planetary group, influenced by space radiation, Oumuamua's color could also involve iron, as suggested by Dr. Meach, a cosmologist at the University of Hawaii's Institute. However, despite these insights, Oumuamua's origin and nature remain a mystery. This trajectory puzzled scientists, indicating something beyond normal explanations. Different theories arose to make sense of Oumuamua's identity. While some trusted it to be a rock, others suggested it was made out of gas. Incredibly, a subset of experts even entertained the possibility that it could be an alien spacecraft. This raises the interesting question: could an extraterrestrial mothership someday explore our nearby planetary group, carrying smaller probes to investigate planets? In the subsequent segment of this video, we will delve further into these secrets. But first, let's examine the range of scientific proposals that have been put forward to interpret the origin of Oumuamua. Dr. Meach proposed the idea that it could have been flung out from a distant star following a cosmic explosion blast or perhaps formed when two objects collided. Additionally, astronomers were initially excited when they saw its trajectory pointing towards Vega, the brightest star in the Lyra constellation, known to have a debris disk. Calculations showed that this object might have come from Vega to our location in about 600,000 years. However, the probability of Vega being the actual source has decreased due to significant changes in its trajectory. It's believed that Oumuamua encountered a new star system for the first time considering its motion around the Sun, which was similar to the speed of neighboring stars. Regardless, there's plausibility, as suggested in nature, that Oumuamua could have been traveling around the galaxy for billions of years. We're uncertain about its forthcoming trajectory. Imagine it like this: remember how the Voyager spacecraft got a speed boost from Jupiter? Well, Oumuamua is also gaining speed from the Sun, moving it faster and somewhere new. Dr. Meach explained that this asteroid, along with its companions, alters our view of the universe. Picture this. When you gaze up at stars appearing distant and isolated, it contrasts with what these space rocks reveal. They tell us that things are interconnected and unique. The oxygen and iron inside our blood emerged from a massive explosion in a distant place long ago. The shiny things like wedding rings resulted from the collision of superdense stars and those meteorites plunging to Earth. Some of them originated from Mars due to asteroid impacts. Remarkably, some respected scientists consider that these meteorites might have carried life from Mars to Earth during a time when Mars enjoyed warm and wet conditions. Life could have begun there and then hitched a ride on those meteorites to Earth. It's a bold idea, but it's being studied by respected cosmologists. Our connection to the universe can be traced even further back in time. Consider the millions of years Oumuamua could have taken to arrive here. While that may seem lengthy, it's just a fleeting moment on the cosmic scale. The Milky Way galaxy boasts an age of 10 billion years. Throughout this vast time span, Oumuamua could have journeyed through approximately 20,000 star systems, a modest number compared to the galaxy's 200 billion stars. But countless cosmic encounters Oumuamua would have trailed behind dust and debris, allowing the stars and the galaxies of the galaxy to intermix. This suggests that the universe might be smaller in scale than previously thought. Even if it's no longer within our nearby view, the planetary system hasn't abandoned it. Now, Elon Musk and other astronomers predict that Oumuamua will enter the Kuiper Belt around 2024 and cross its edge by late 2025. He also estimates that it will pass the Voyager spacecraft's farthest point in 2038. However, since Oumuamua has been distant for astronomers, they are making the most of the data gathered in just a few months to understand as much as possible about this intriguing interstellar intruder. Initially confused with the asteroid due to its size of around 2,600 feet long and 260 feet in width, Oumuamua displayed eccentric behavior in its trajectory. Astronomers and scientists observed an outstanding non-gravitational acceleration, indicating that forces beyond gravity were influencing its motion. Dr. Meach figured that several factors could lead to this acceleration. Her team examined at least 6 potential causes, ruling out some due to their improbability or inconsistency with observations. One likely explanation was comet outgassing, a common occurrence in comets. Outgassing happens when a comet gets close to the Sun and its surface ice sublimates, going directly from solid to gas. This process gives the comet an extra push, altering its speed and trajectory beyond gravitational influence. This change in motion resembles the behavior of Oumuamua, lining up with the non-gravitational acceleration seen in comets. Notably, the absence of visible dust from Oumuamua was captivating. Typically, as gas leaves a comet, it carries surface dust with it. However, Dr. Meach states that even if the comet lacked microscopic material, the likely presence of substantial dust on its surface could have been affecting its speed. This idea kept the possibility of it being a comet alive. Additionally, scientists critically examined apparent frequencies, which make it challenging to subsequently detect large dust particles. No apparent evidence of dust leaving Oumuamua was observed. The lack of gas-related signals was also puzzling. Surprisingly, astronomers expected an observable amount of gas emission to affect Oumuamua's speed in the way observed. Dr. Meach's team specifically searched for CN gas, a substance that she notes is bright and easily detectable. It serves as a proxy for water, which is harder to monitor since CN is often released from comets in our nearby planetary group alongside water. Curiously, despite their efforts, no CN gas was detected within their detection limits. Considering that comets in our nearby planetary group can retain significant amounts of water, the absence of CN gas indicated that this comet was chemically unique. Dr. Meach figures that if a large volume of water were to be emitted, it would likely originate from a different nearby planetary group, and this could account for this unusual finding. Astronomers used the Spitzer Space Telescope to observe Oumuamua in the infrared for over 30 hours, attempting to detect its thermal characteristics. However, they encountered challenges in their endeavor. Dr. Meach explains that the thermal infrared detects heat emissions, and in this case, their observation yielded no visible results. Interestingly, even non-detections can offer insights. In this case, they concluded that Oumuamua must be brighter than expected if it exhibits thermal behavior similar to a comet. The reflectivity of an object, or how much light it reflects, can reveal details about its size, structure, and shape. We generally expect the reflectivity to resemble that of comets, which is very low, Dr. Meach figures. But they were getting readings around 10% reflectivity, rather than the typical 4% reflectance typical of comets. So it doesn't quite fit the profile of a comet. To make it match that 4% reflectivity, you'd need to assume it has significantly different thermal properties on its surface compared to other comets. This is another interesting peculiarity. Moreover, during the same infrared observations, no detectable carbon monoxide or carbon dioxide outgassing from Oumuamua was observed. This finding holds significance since Dr. Meach's group had been considering how likely it is that Oumuamua was releasing these two gases in larger quantities than the Spitzer's observation limits suggested. It's a little challenging to infer much when you don't see, but again, it doesn't seem to act like a typical comet. Given that Oumuamua hailed from a different planetary system, these peculiarities could be characteristic of objects originating from other star systems. The trajectory of Oumuamua was meticulously traced back to before its initial entry into our planetary system by Corin Baylor-Jones from the Jet Propulsion Laboratory. Comparing this path to the past positions of 7 million stars tracked by the Gaia space probe, Baylor-Jones rewound both Oumuamua and the star's orbits to identify potential points of crossover. Out of the stars with trajectories that approached close enough to Oumuamua's rewound path, 4 contenders stood out as potential candidates for its home. Elon Musk claims that Oumuamua's trajectory had intersected within a range of 1 to 2 light-years or 100,000 to 200,000 astronomical units. However, as Baylor-Jones was stargazing, complications arose. The escape speeds of these contenders were relatively high, ranging from around 6 to 16 kilometers per second. A potential complication, Oumuamua is likely a planetesimal, a structure cast out during the formation of planets. It's rare for planetesimals to achieve escape speeds this high solely through interactions with large planets. Our predictions would have suggested speeds of just a few meters per second. While these speeds are high, they are not impossible but highly improbable. The scenario becomes more plausible if Oumuamua originated in a binary star system. However, the contenders were not necessarily recognized as binary stars typically. Upcoming data releases from the Gaia mission could help astronomers in identifying a more plausible source for Oumuamua by offering further insights into the movements of neighboring stars. In a few years, it would be fascinating to revisit this, the first and so far only extraterrestrial guest we've observed navigating our planetary system remains Oumuamua. Even with the limited data available, despite its puzzling nature, experts worldwide are fascinated by its potential secrets. Indeed, Oumuamua continues to captivate due to its unconventional attributes. Now, it would seem Oumuamua isn't on its own. Back on August 30, 2019, Gennady Borisov, a novice astronomer at the Margot Observatory in Crimea, detected another comet named 2I/Borisov. This comet was dashing through space at a surprising rate of 93,000 miles per hour, 150,000 kilometers faster than what you'd expect for an object situated around $2.80 away from the Sun. What caught our eye, other than its speed, was its trajectory. It was diving into the interplanetary system at an angle of 40 degrees relative to the ecliptic plane, on a path marked by an extremely high eccentricity of 3.7. This indicated that, similar to Oumuamua, Borisov also had an extrasolar origin. Borisov displayed a distinct tail, unmistakably marking it as a comet. Its trajectory was taking it toward the Sun, expecting to reach its closest point on December 8, 2019, at around $2 from our star. This would illuminate it before darkening again, potentially reaching size 15 by its closest pass to Earth on December 28. Even after it dimmed for amateur spectators, experts could continue tracking Borisov until October 2020. Dr. Micha's team first observed Borisov and estimated its size to be between 1.2 and 10 miles in October 2019. They observed the emission of CN gas from its surface in October 2019, but the comet's faintness prevented the detection of other gases. However, the extended year of observation provided by Borisov's trajectory offered a unique opportunity to explore its chemistry. This stands in contrast to Oumuamua, which didn't allow for detailed chemical analysis due to potential impediments due to gas and dust. This extended observation will shed light on 2I/Borisov's specific comet-like appearance, making it a red-tone traveler that aligns more with our typical understanding of nearby comet-like comets. This uniqueness highlights the diversity in interstellar objects. Such differences are crucial for astronomers striving to understand the processes shaping other planetary systems, whether similar or distinct from our own. This ongoing investigation broadens our perspective on the wider universe. Meanwhile, some astronomers have dared to propose that Oumuamua may be of extraterrestrial origin, adding to the intrigue. A draft paper by a Harvard scientist and the head of the Pentagon's UFO office suggested the possibility of an extraterrestrial mothership within the planetary system, dispatching microscopic probes akin to dandelion seeds to explore the planets. The disclosure of this document came from Sean M. Kirkpatrick, the director of the Pentagon's All-Space Anomaly Resolution Office, AO, established in July 2022 by the Department of Defense, DoD, to identify and investigate intriguing objects. Collaborating on this draft study alongside the DoD was Avi Loeb, an astronomer at Harvard University. However, noting that it's significant, the study is not an official Pentagon report. Loeb is renowned for his research on Oumuamua, having even suggested the idea that Oumuamua may be an extraterrestrial spacecraft 6 months before Oumuamua's close approach to Earth. A small interstellar meteor approximately 30 meters in diameter struck our planet. Although irrelevant to Oumuamua, this meteor, known as M2, caught Loeb's attention. By chance, Loeb considered how possible it is that a fake interstellar object could act as a parent craft, releasing multiple small probes during its passage close to Earth, an idea akin to NASA's spacecraft missions. The residual gravitational force from the Sun or the craft's propulsion may detach these dandelion seeds from their parent vessel. In their draft study, Loeb and Kirkpatrick delved into unidentified aerial phenomena, UAPs, a term preferred by the government for UFOs, while adhering to established physics. The researchers speculated that the dandelion seed probes could travel to Earth for observation without being detectable by survey telescopes, likely due to their small size, which would limit their sunlight reflection. According to their proposal, the technology of these probes could allow them to slow down in Earth's atmosphere to prevent burning up, thereby utilizing their parachute-like mechanisms to navigate to their intended destinations after landing. Scientific conjectures suggest that alien civilizations could prefer to focus on rocky planets with atmospheres within our planetary system. Planets like Venus, Earth, and Mars would undoubtedly pique their interest. After identifying signs of liquid water, the mothership wouldn't necessarily have to be home to the advanced extraterrestrial civilization that created the probes. The possibility of the mothership communicating with these probes is also uncertain. The idea that a habitable planet with intelligent life could have dispatched probes long before Earth existed is a fascinating proposition. Loeb compares it to periodically checking our mailbox for accumulated packages, even if the senders are no longer extant. Loeb has faced skepticism from mainstream scientists since he first proposed the idea that Oumuamua could be an extraterrestrial spacecraft. Some critics view his speculation that Oumuamua was intentionally sent to Earth as provocative and lacking a solid foundation. In 2021, A letter published in the journal Astronomy and Astrophysics refuted the idea of interstellar travel, citing cosmological timescales required to traverse between stars. The authors concluded that its unlikely Oumuamua was sent by an extraterrestrial civilization, more likely attributing it to an unusually shaped rock that happened to wander into our planetary system. Another study has actually debunked the notion that Oumuamua's mysterious movements could be attributed to an extraterrestrial spaceship. Instead, it provides a possible explanation suggesting that hydrogen off-gassing, which occurred on September 22, 2021, was responsible for the observed acceleration.